Hello. Today I want to introduce the topic of orthogonal bases. And to start with this, I want to introduce the following setting. So let U and V be non-zero vectors of Rn, where U is orthogonal to V. Now, what does this mean? Well, it means that the dot product between U and V is equal to 0. In other words, U transpose times V is equal to 0. So, since we want to talk about bases, we need to introduce sets of vectors which are linearly independent. So, a natural set to introduce here is the following. And a question arising from here. Is the set consisting of vectors u, v linearly independent? Well, let's see. Let alpha and beta be real numbers and assume that alpha times u plus beta times v is equal to the 0 vector. Now, if we have this equation, this homogeneous equation, we want to see what is the interaction between this equation and that one. So to do that, I'm just going to simply multiply by U transpose. So to get this, U transpose times alpha U plus beta V equal to U transpose times the 0 vector. Now let's reduce this equation. What we have here is the following. U transpose times alpha U plus U transpose beta V equal to 0. Well, simply multiplying these two. But now let me manipulate this, and I will write it in the following form. By properties of the scalar product, this is alpha U transpose times U plus beta U transpose times V equal to 0. But let's not forget, this product that we have here is exactly 0 because these two vectors are orthogonal to each other. So now I have this, alpha times U transpose times U is equal to 0. But we have seen this quantity before. This is the norm of U squared. So I get the following equation. So I have that alpha times the norm of U squared is equal to 0. But let's not forget, the U that we have here is non-zero. So it cannot be that this norm is equal to 0. And this is simply a product of two real numbers. So I have this. Then either alpha is equal to 0 or the norm square is equal to 0. But U is different from 0. So this is different from 0. The only possible conclusion that we get from here, the only logical one, is that then alpha is equal to 0. Well, let's see. We got one. Let's see if we can clear up the other one. But remember, the dot product is commutative, so we also have this. Recall that U transpose V is equal to V transpose U.